Today we are inside a real detergent factory preparing a full 1,000-liter batch of laundry detergent from start to finish. This is not a laboratory demo and not a fake social media setup. Everything you see here is the same process used in small and medium commercial factories every day. In front of us is a stainless steel mixing tank equipped with a heavy-duty agitator system designed for chemical production. The tank is connected to a variable speed control cabinet, so the mixing speed can be adjusted during different stages of production. Around the tank, you can see raw materials carefully prepared before mixing begins. The most important lesson for beginners is this. Good detergent does not come only from the formula. It comes from the correct mixing process, the correct order of ingredients, and proper control of mixing speed. Many new factories copy formulas from the internet, but still fail because they ignore the production process itself. Some products become too watery, others separate after a few days. Some lose fragrance quickly or create too much foam during production. All these problems usually begin with poor process control. Before we add any chemical into the tank, we first inspect the machine. The agitator shaft must rotate smoothly. The motor temperature must be normal. The inside of the stainless steel tank must be completely clean and free from old residue. Even small leftover chemicals from previous batches can damage the quality of the new product. Today, this batch is being produced using a real industrial agitator designed for detergent manufacturing. The mixing blades are designed to create strong circulation without trapping too much air inside the liquid. This is extremely important because excessive air creates unstable foam and reduces product quality. During this video, we will show the exact production sequence used by many detergent factories, including raw material weighing, loss addition, SLES mixing, viscosity adjustment, fragrance blending, quality control, and final filling. Every step matters if you want a stable and professional detergent product. Before any chemical enters the mixing tank, the first job is accurate weighing of raw materials. In detergent production, even a small measuring mistake can affect the final product quality. In this factory, every raw material is prepared in separate containers before production starts. The main surfactants used in this batch are loss and SLES. Loss is responsible for strong cleaning performance, while SLES improves foam and washing stability. We also prepare water, salt for viscosity adjustment, fragrance, color solution, preservative, and supporting additives depending on the product type. One of the biggest beginner mistakes is pouring materials into the tank while still calculating the formula. Professional factories never work that way. Everything must be measured first before the mixer starts. The operator uses a digital scale to ensure accurate quantities. The water is added first because it creates the base environment for dissolving chemicals safely. If concentrated surfactants are added directly into an empty tank, they can stick to the stainless steel wall and create thick chemical lumps that are difficult to dissolve. Another important detail is water quality. Clean water helps detergent remain stable longer and improves product clarity. Some factories use untreated hard water and later wonder why their detergent becomes cloudy or separates after storage. Around the tank, you can see each raw material labeled clearly. This is an important habit in real factories because confusion between chemicals can destroy an entire batch. The operator also checks the room temperature because extreme temperatures affect mixing performance and viscosity behavior. During large-scale production, organization is just as important as chemistry. When everything is prepared correctly, the production process becomes smoother, faster, and safer. A clean production environment also improves worker safety and prevents cross-contamination between batches. Once the water level is ready and the agitator begins rotating slowly, the factory is ready for the next stage, which is adding loss into the mixing tank carefully and controlling the reaction during the first major mixing phase. Now the first major surfactant enters the production tank. Loss is added slowly into the circulating water while the agitator rotates at controlled speed. This stage is extremely important because loss is highly concentrated and can create serious clumping problems if added too quickly. In many failed detergent batches, the problem starts right here. Beginners often dump loss directly into the tank in one large amount while the mixer is running too slowly. The result is thick chemical lumps forming around the mixing blade and tank wall. Those lumps sometimes never dissolve completely and later appear as unstable gel particles inside the finished product. In this factory, the operator pours loss gradually while carefully observing the liquid movement inside the tank. The agitator creates strong circulation that pulls the chemical evenly through the water. The goal is smooth dispersion without excessive foam or localized concentration. Close-up shots of the mixing surface show how the liquid changes color and texture as loss begins dissolving. Another important factor is mixing speed. If the speed is too low, the chemical will not disperse properly. If the speed is too high, too much air enters the liquid and creates unwanted foam. Professional detergent production is about balance. The operator also watches the motor load and sound during this process. Thick chemicals increase resistance inside the tank, and overload can damage the machine over time. Real factories constantly monitor both chemical behavior and machine performance together. This is why industrial detergent mixers use strong gearboxes and durable shafts designed for continuous operation. After the loss fully disperses, the liquid becomes more active and slightly thicker. At this stage, patience is critical. Rushing production causes instability later. The mixture must circulate long enough to become fully uniform before the next surfactant is introduced. Once the operator confirms there are no visible clumps and the liquid surface is stable, the production process moves into the next stage, which is adding SLES, while controlling foam generation inside the tank. The next ingredient entering the mixing tank is SLES, which is one of the most important foam-producing surfactants in laundry detergent manufacturing. Compared with loss, this material behaves differently during production. SLES is thicker and can generate large amounts of foam if handled incorrectly. That is why professional factories never add SLES aggressively. In this production process, the agitator speed is reduced slightly before the material enters the tank. This helps minimize trapped air inside the liquid. The operator slowly introduces SLES near the circulation zone where the liquid movement is strongest. If SLES is dumped carelessly into one location, it can create thick floating masses that dissolve very slowly. Excessive foam is one of the biggest production problems in detergent factories. Foam not only slows production, but also creates inaccurate tank volume readings and increases the risk of overflow. Many beginners think more foam means better detergent quality. In reality, uncontrolled foam during manufacturing is usually a sign of poor mixing control. Inside this stainless steel tank, you can see smooth circulation without violent splashing. This is exactly what professional detergent production should look like. The mixer is designed to move liquid efficiently while keeping the surface relatively calm. Close-up shots show the texture becoming richer and more uniform as SLES blends with the loss solution. The operator occasionally checks the side wall of the tank to ensure no thick chemical residue remains attached to the stainless steel surface. Clean mixing patterns are important for consistent product quality. Another key detail is production timing. Every factory develops mixing durations based on tank size, agitator power, and chemical concentration. Rushing this stage can create long-term instability that only appears after packaging. Some products look perfect on the production day, but separate later because the surfactants were never fully blended. After enough circulation, the liquid begins developing the familiar appearance of commercial laundry detergent. The foam level remains controlled, and the mixture becomes smoother with every rotation of the agitator. Once the operator confirms stable blending, the process continues into anti-clumping control and chemical stabilization. One of the most important skills in detergent manufacturing is preventing clumps and chemical separation. Many new producers focus only on cleaning power and fragrance while ignoring stability. A detergent that separates after a few days will immediately damage customer trust. Inside this factory, the operator carefully monitors the mixture after the main surfactants are blended. At this stage, the liquid may appear smooth from the top, but hidden problems can still exist inside the tank. Thick concentrated areas sometimes remain near the bottom or around the mixing shaft if circulation is not strong enough. To prevent this, the agitator continues operating at controlled speed while additional supporting ingredients are introduced gradually. Some chemicals must be pre-diluted before entering the tank. Direct addition of concentrated materials can shock the mixture and create unstable reactions. The operator uses visual inspection together with production experience to judge liquid behavior. Small texture changes often reveal problems before they become serious. Close-up camera angles show the liquid flowing smoothly through the tank without visible particles or gel lumps. Professional factories also avoid sudden changes in mixing speed because aggressive turbulence can trap excess air and destabilize the product. Another common cause of separation is incorrect ingredient order. Even high-quality chemicals can fail if introduced at the wrong stage. That is why experienced detergent factories follow strict production sequences every day. The stainless steel mixing system also plays an important role. Tanks with poor internal design create dead zones where chemicals do not circulate properly. This factory uses a mixing configuration designed specifically for detergent production to ensure complete movement throughout the entire tank volume. During production, the operator occasionally pauses near the inspection opening to observe liquid consistency directly. The goal is a completely uniform mixture from top to bottom. Stable detergent should maintain the same appearance throughout the entire batch. Once the operator confirms proper blending, the process moves into one of the most sensitive stages in detergent manufacturing, which is viscosity adjustment using controlled salt addition. Now we arrive at one of the most critical stages in detergent manufacturing, which is viscosity adjustment. This is the process that determines whether the detergent feels too watery or too thick inside the bottle. In many factories, this stage creates the most production mistakes because viscosity changes can happen very quickly. The operator prepares a salt solution separately before adding it gradually into the mixing tank. Salt is commonly used to increase thickness in detergent formulations, but too much salt can completely destroy product stability. Beginners often panic when the detergent still looks thin and immediately add excessive salt. A few minutes later, the product becomes overly thick and difficult to pump or fill into bottles. In this factory, the agitator speed is carefully controlled during viscosity adjustment. Slow and stable circulation allows the operator to observe texture changes accurately. Close-up shots show the detergent moving differently as thickness increases. The liquid begins forming smoother waves and stronger surface patterns inside the stainless steel tank. Professional factories never rely only on visual judgment. The operator checks flow behavior and mixing resistance continuously during production. Another important lesson is patience. Thickness does not always appear instantly after salt addition. Some formulas require several minutes before reaching stable viscosity. That is why experienced operators always add salt gradually while waiting between adjustments. Temperature also affects viscosity significantly. Warm detergent usually appears thinner, while cooler product becomes thicker. Real factories understand this and avoid making aggressive corrections too early. Inside the control cabinet, the variable speed drive allows precise adjustment of agitator rotation depending on product behavior. This is one major advantage of industrial detergent mixers compared with simple homemade systems. Once the detergent reaches the desired texture, the operator stops salt addition immediately and allows the mixture to circulate for final stabilization. The liquid now has the rich appearance customers expect from commercial laundry detergent. The next stage will focus on fragrance blending, color adjustment, and preparing the batch for final quality inspection before filling. With the detergent now fully stabilized, the production process moves into the finishing stage where fragrance and color are added carefully into the mixing tank. This stage may look simple, but it has major influence on customer perception. A detergent can clean extremely well, yet still fail in the market if the fragrance is weak or inconsistent. In this factory, fragrance is never added at the beginning of production because aggressive mixing and concentrated surfactants can damage delicate scent compounds. Instead, the perfume is introduced only after the main chemical reactions are complete and the viscosity is stable. The operator reduces agitator speed slightly before adding fragrance to prevent excessive evaporation and foam formation. Close-up footage captures the fragrance entering the smooth circulating liquid while the detergent develops a more polished commercial appearance. Color solution is also added gradually. Professional factories avoid overcoloring because customers often associate overly bright detergent with cheap production. The goal is clean and attractive visual consistency. During this stage, the operator carefully observes the tank's surface and sidewalls to ensure fragrance and color disperse evenly throughout the entire batch. Uneven mixing can create shade variation between bottles during filling. Another important detail is production environment cleanliness. Strong fragrances from previous batches can contaminate new products if tanks are not cleaned properly. That is why real factories follow strict cleaning procedures between production cycles. The stainless steel interior of this tank allows easier washing and reduces chemical residue buildup. As the agitator continues rotating slowly, the detergent becomes fully uniform in both texture and appearance. The operator occasionally collects small liquid samples to smell and inspect directly under factory lighting. Commercial detergent production is not only chemistry, it is also sensory control. The final product must look professional, smell clean, and maintain stable texture over time. Once the operator confirms that fragrance, color, and viscosity are all balanced correctly, the production process enters the final quality control stage before the detergent can move into packaging and filling. Before any detergent enters bottles, the factory performs a final quality control inspection. This stage protects both the customer and the reputation of the manufacturer. Even if the product looks good inside the tank, it still must pass several important checks before filling begins. The operator first measures product pH using a digital pH meter. Correct pH balance is extremely important in laundry detergent because overly acidic or overly alkaline products can irritate skin and damage fabric over time. The pH result must remain within the target range developed for this formula. Next, the operator evaluates viscosity again because detergent thickness can change slightly after full stabilization. A professional product should pour smoothly without feeling either too watery or excessively thick. Close-up footage shows the detergent flowing from testing containers while the operator checks consistency under factory lighting. Foam performance is also inspected using a simple agitation test. The goal is stable cleaning foam without abnormal collapse or excessive air trapping. Some factories also perform quick washing demonstrations using fabric samples to verify cleaning behavior visually. Another key inspection point is clarity and separation resistance. The operator observes the liquid carefully to ensure there are no floating particles, gel lumps, or oil separation inside the sample container. Stable detergent should maintain uniform appearance throughout the batch. The factory also checks fragrance consistency because uneven perfume blending can create customer complaints later during packaging distribution. During this stage, machine performance remains important as well. Pumps, transfer hoses, and filling systems are inspected before production continues. A good detergent can still be ruined by contaminated filling equipment. The operator records final production information including batch number, mixing time, and inspection results for quality tracking. Real factories rely on documentation to maintain consistent standards over long-term production. Once every test passes successfully, the detergent is officially approved for filling and packaging. The final stage will show the completed product moving through the real factory filling process and reveal the finished commercial detergent ready for customers. After hours of controlled mixing, stabilization, and quality inspection, the 1,000-liter detergent batch is finally ready for filling and packaging. The transfer system connects directly from the stainless steel mixing tank to the filling machine to minimize contamination and reduce unnecessary handling. Inside, the factory workers prepare clean containers, caps, and labels before filling begins. Close-up shots capture the detergent flowing smoothly through hoses and into finished bottles. This is the moment where all the earlier production stages become visible in the final commercial product. The detergent now has stable viscosity, clean fragrance, balanced foam, and uniform color throughout the entire batch. Professional factories understand that customers judge quality immediately from appearance and pouring behavior. If the product looks separated, overly watery, or inconsistent, customer trust disappears quickly. That is why careful process control during production is more important than simply copying formulas from the internet. Throughout this entire manufacturing process, several critical lessons became clear. Raw materials must be weighed accurately. Ingredient order matters. Mixing speed must remain controlled. Foam must be managed carefully. Salt adjustment requires patience. And machine maintenance is essential for stable production. Many small factories fail not because of bad ingredients, but because of poor production discipline. Here inside this real detergent factory, every stage is performed methodically using industrial mixing equipment designed specifically for chemical manufacturing. The stainless steel tank heavy-duty agitator, and controlled circulation system all contribute to stable product quality. Final shots show rows of completed detergent containers ready for shipment while the mixer continues rotating slowly in the background. This is real factory production without fake demonstrations or artificial shortcuts. From raw chemicals to finished bottles, every step follows practical industrial manufacturing methods used by professional detergent producers every day. For anyone planning to enter detergent production, the most important investment is not only the formula, but also understanding the process behind making a stable and reliable product.